Okay.
Able to join us tonight, or?
I have no idea. I was under the impression you would. So, you just want to dive into it?
Maybe go ahead and see if he comes in. Okay. Let me pull up the questions here.
Yeah. I was in the middle of doing my math lab homework, so I think I kind of understand it.
Really?
Yeah, but I'd like some more practice with.
What part were you doing in my math lab? Like what topic?
Lesson on the sum to product to sum. So I was just doing that.
Okay. Yeah.
What I don't get is they ask you to write it in the form of, let's see if I can find it. It's a sine x plus a. They use a different symbol for the angle. I haven't quite those questions yet, but I'll get to that.
For that too. And the PowerPoint we have for that doesn't explain too much.
No, it doesn't really tell you what.
I have looked at other sources since I've looked at this too, so I've been trying to piece the puzzle pieces together, but
yeah.
As for like our group video things, like our materials, I think I've got it. First question theorem was kind of confusing for me, but I got it. Like I started trying to work it out, each one of them, and I think I've got the right answers, but I'm not sure either. Maybe your theorem, but it confused me. So do you want to start the questions on the extension, or?
Sure.
Okay.
I'm
well,
over the purpose for preparation. Is that okay with you?
I didn't hear the first part. What were you saying?
I wasn't gonna do questions. Or you look at the preparation.
I'm looking at it says team discussion, reduction theorem, and then it shows us. Yeah. Okay, yeah. So did you want to start with reduction theorem, or do you want to go through the preparation assignment?
I do not want to do the preparation assignment.
Okay, that's what you said. I'm sorry, you're breaking up, but I totally agree with you. So let's I guess are we doing the reduction theorem? I was confused because I worked through those.
Yes.
Okay. So that's William.
Man. What? Okay. I only sent him the invite 3 times.
Are we still doing it?
All right. So reduction theorem for the first one. I have to kind of rush through this. I'm watching my daughter by myself tonight.
Hey, you're good. You're good. Yeah, let's.
Is reduction theorem just about reducing identities?
Reduction theorem is separating it and making it equal to 0. And if there's some kind of identity that we can substitute for, when we use that. But these problems right here are pretty straightforward.
Okay.
The second an identity is 0, and then you get your answer from that.
So you make the equation equal to 0.
Yes.
So you just solve for one side.
Yeah, and and then you can solve for sine and then cosine separately, and from that, when you make it equal to 0, you get your
Okay, so I'd do sine
value.
negative sine x equals 0, and then square root of 3 cosine is equal to 0. Is that what you're saying?
Well, you make the whole thing equal to 0.
Okay.
So by doing that, you plus square root cosine x, then you take the side and then 3. So that's your answer right there. So so and then after you solve for tan x, you can solve by itself. So sine x is pretty simple. Sine x equals square root 3 cosine x. I get that here. Tan x. Sine plus 3 sine equals square root 3 cosine x. Um, are you still number 1? Like, do you have any questions?
Yeah, give me a second though.
No, you're good. As for graphing it, I didn't get to graph the function, but
All right, so you just resolved it to sine of x equals square root of 3 cosine x.
yeah, so that's the part like I said in the beginning, the first one, I couldn't solve that. Like I didn't know where to go from there. But I did get tan x, and that did give me one answer that I could use in the solution.
How'd you get the tangent of x?
So I moved negative sine x to the other side. And so you had square root 3 cosine x equals sine x. And then you divide both sides by cosine x. And then so you have square root of 3 equals sine x over cosine x, which is tan x.
That makes sense.
And so you have one answer, but I couldn't figure out how to get sine x by itself, honestly. So
I have a different. So I'm looking at the textbook.
yeah.
The reduction formula is the square root of a squared plus b squared.
Okay,
Does
yeah.
that sound right?
Uh-huh.
So is that what we're supposed to do?
See, that's
And then you can find tangent.
like that's what I did in the. So I'm guessing for that one that's what you do.
Instead?
I did different things and I got the answers for it. So I don't know what we're really supposed to do with the reduction theorem. Like they're getting these for all of them here. Like that's what I mean.
You're breaking up really bad. So I heard something about the reduction theorem, but that was it. It may not just be you. My daughter's watching
really?
loudly, so.
All right.
Hear anything. So I have, using the reduction theorem, I have A as 2. Yes, Lucy? Lucy, you're okay.
I need more milk.
You don't need any more milk.
Yeah.
One more. Hi. 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 Hi.
All right. Give me a second. Apparently I have to go refill her bottle. Is he on? Here, sweetie. All right. Sorry about that. So with the reduction theorem, the actual reduction is really easy. I've just never understood where to go from there. Like what to do with it after that. If that makes any sense. You still there, Pablo? You're free. Your screen is frozen.
No, it does. Like I get to a certain point and then I don't know what to do after that too. So yeah, I'm still here.
I know. I don't remember exactly how it works. And the textbook is horrible. There's only one example, and they decided to use a spring. So they don't use sine or cosine of anything. They just go straight into a physics equation.
It's really unclear. Yeah.
Wonder.
So yeah, as like I was saying, the first one, like I'll try to figure out. But you said you got a equaling 2, or 2 would be for a.
The reduction is a, and a is 2. So then I know what you do is you take the coefficient of either sine or cosine, and you put that above 2. So sine would be negative 1/2, and cosine squared is 3/2. What I do not know is what that, like if you put the negative 1 in front of the sine over 2, I don't know if that's the sine or the cosine. I don't know what I just solved for. And that's where I get confused.
Huh.
So that's what I'm trying to figure out right now. Go in here real fast.
That's why I thought solving specific.
No, I actually didn't see the formula.
Is that William?
William says it's died.
Is he in this right now?
I can't understand a word you're saying.
Yeah, he is.
Okay. So I know what we solved for. You still there? So the reduction PowerPoint, gives you
Yeah,
all
I'm still here. Can you hear me?
Wait, you sound like a robot. Oh, there he is. What's up, William?
Yeah, I'm using my phone now because I had to install the Hangouts in my phone, and I'm using my phone because my computer, I don't know what happened.
Computers do funny things. All right, so we're still working on the first problem in the reduction
There
theorem.
it is. You want to turn it on?
Sorry.
Yeah. Okay, we are on the first problem.
The Apple Store. Yeah, we're still on the first problem.
Okay. I cannot see the problem right now. I would try to open in my computer. Just give me a sec. In my cell phone.
Pablo, you still there? You're frozen.
Who is frozen? I'm frozen?
Frozen.
Oh, Pablo.
All right, well, while you two are trying to get everything together, I need to take some notes.
What is this music?
My daughter is watching Kung Fu Panda,
Oh, gotcha. Which one?
the third one.
Oh,
The
the
new
third
one.
one is really good. Yeah, I watched that with my daughter too.
Well, I don't know why she's obsessed with it, but she's only 2 years old, and she will watch Finding Nemo and Kung Fu Panda, and that's it.
Yeah, my daughter, she's almost 2. She's gonna turn 2 in February, and about 2 months ago, she was all about watching Tarzan, and I
Yeah,
think that I watched that movie like probably like 5 to 6 times a day, and I knew every single every single thing that they would say in the cartoon and everything.
yeah, we've gotten to the point where my wife and I will turn on. We'll just leave the room because we know it word for word all through the movie.
Yeah, and now my daughter suddenly just changed, and now everything is frozen.
See, and I still, despite the fact that my wife loves Frozen, my daughter won't watch it as much.
Oh,
She'll make it right up to the trolls when the trolls do their song, and
yeah.
she stops watching it.
Oh, really? My daughter is, man, she's fascinated. She's always, and she is the only name that she knows how to pronounce is Anna. So, and it's all the time. It's like Anna, Anna, Anna.
Yeah.
Here, so are you guys going over the questions for the Google Hangouts meeting or the prep?
Yeah, the Google Hangouts.
Okay.
We're ignoring the preparation questions.
Okay.
Lucian, you're all right.
Okay, I open it on my cell phone.
You got it?
Oh no, I tried to open it, it's saying page not found.
All right. Can we just tell you the questions? Or you know what?
Wait.
Can you see me?
I would try to borrow my wife's computer.
Okay. If you can see me, I'll just put it up on the screen.
Yeah, this is my daughter right there doing her stuff.
Oh, what's her name? There. You want to say hi?
Hi.
This is Lucy. Are you watching Kung Fu Panda?
Say hi.
Hi.
Can you say hi? Can you see the little girl right there?
Hi. Here. Oh.
Hi, little girl.
Hi.
Hi. Hi.
Yeah, now we have a Now we have a Google. Let's we can put our daughters to do the meeting for us, and then we just relax.
Yeah, I don't want to do golf anymore. We're just gonna do this.
Yeah.
My wife.
Say bye bye. Bye bye. Bye bye.
Bye-bye.
All right, my daughter just ran out of the room.
Yeah.
Hey, thank you. I found my way back.
All
Can you
right,
guys
so
hear me?
Pablo, I figured out how to do the questions.
Oh yeah.
Yeah,
How's?
I'm just waiting for William to get online where he can see them.
Oh, okay.
Yeah. Wait. Just tell me the question, then I might remember because I did all those questions. So.
Because your memory is just
Which
that
question?
good. First question: of sine of x plus square root of 3 of cosine of x. Then they say use the reduction theorem to graph the function. Since it's the graphing, we'll just solve for the equation.
Oh, gotcha. Me.
The reduction, it's square root of a squared plus b squared, which is square root of negative 1 squared, 4.
Oh, okay. I see what you're saying.
2.
Yeah. Yeah, I do.
Okay. Then the formula for the sine and cosine from that is sine of x would equal b over a. Sorry, b over the reduction a that you just found.
Yeah.
And then cosine is a over the reduction. So in this case, sine would wind up being square root of 3 over 2.
Okay.
And then cosine would be negative 1 over 2. And at that point, we have our trajectory. So then all you have to do is find the match on the unit circle.
Okay. Yeah.
Is 1/2. It would wind up being 5 pi over 6. And that's your solved angle.
5 pi over 6.
Does that sound right?
And that's our answer then and there. Just 5 pi over
Yeah.
6. Or we're putting it into that form, correct?
You. No,
A
you're
sine x plus.
Yeah, a sine of x plus c. And I don't understand how to set that up. Do one of you know that?
I'm trying to remember what the reduction theorem is.
Reduction theorem is the square root of a squared plus b squared. A and b are the coefficients in front of sine and
Oh,
cosine.
gotcha.
So
Yeah,
wouldn't
yeah.
it be 2?
I know exactly. It's just it's just putting the changing the equation and writing it in that form that we learn in. Yeah.
So all it is a, which we solve for, is 2. Sine parentheses x plus 5 pi over 6.
Yeah, and in this case, a is -1 and b is square root of 3, right?
Yeah.
Yeah. Sorry,
And then you do the square root of the square of both, the sum of both squares, and then you get a.
Yes.
Okay.
Yeah.
Then besides that, then we find the angle because we have now all the sides of the triangle, so it's pretty easy to find the angle after that.
Yeah. And then you have to
Makes sense
rewrite
to me. I got that.
the sine x plus c, a sine x plus c. which I have as 2 sine x plus 5 pi over 6.
Yeah, because if you have, yeah,
That's
minus 1, the square is going to be 1. And then plus square root of 3, which is going to be just 3. So it's going to be, by the end, it's going to be just a square root of 4, which is 2. So that's a. So now knowing that it's minus 1, square root of 3, and 2, then if we use the, I mean, any inverse function, we can do like inverse cotangent. Oh, inverse tangent, then we have inverse tangent of square root of 3 over 1. And then the angle that has a tangent of square root of 3, then that's 2 pi thirds. And that's C, right? It's the angle.
So yeah, it is 2 pi thirds.
Yeah, because when you,
Five
when you
pi.
take a look, and do we take in consideration goes from positive pi halves to negative pi halves in order to, when we are trying to find the angle? That's something that I don't remember if we do. Do we take that in consideration too or not?
It goes from 0 to 2 pi.
Oh yeah, when we are changing the equation, yeah, that's right. It's just finding the values that fit that from 0 to 2 pi. Yeah, that's right. Okay, so just
Okay.
graphing.
Pablo just disappeared again.
Yeah, that's why he's being so silent.
Yeah, I think our connection's really bad. Okay, so you have 2 pi over third, or over 3, right? That's the angle that you came up.
Yeah, because what I did an inverse tangent
Right.
of, because you know that negative 1 is going to be the x value, and the square root of 3 is going to be the y value, right? So then if we set the triangle with those two sides, then I did a arctangent of square root of 3 over negative 1. So that's going to give us arctangent of negative square root of 3. And from 0 to 2 pi, the angle that has a tangent of negative square root of 3 is 2 pi thirds.
Okay. I'm okay.
Because you're looking for the smallest arc, right?
Yeah.
Because 5 pi thirds with the tangent of negative square root of 3, but because you're looking for the smallest one, then we're just talking about 2 pi thirds.
Okay.
Does it make sense? I mean, the way I did?
I think so.
Okay.
Yeah,
And then,
I can see how it would work. So, okay. I'm satisfied with that. All right, so the second one is solve sine of 2x
yeah,
as
but
equals
we
sine.
need to graph this now, right?
Oh, I'm not going to graph it.
Yeah, but
I don't have any paper handy, and
yeah,
I'm not
but
going to take the time.
But if you want, I can explain really fast. It's just because it's in the regular form to graph the functions, right? That's why we change it to this form, because it's easier to graph this form of the equation than the previous one. So that's why we have this transformation thing, so that we can graph these kind of really crazy
Okay.
equations
Right.
before, and then we can graph it really easy. And what it's telling us is that the A number that we find, that's the amplitude. So it's telling us that we have an amplitude of 2,
Right.
a regular sine function with an amplitude of 2 instead of 1, and it's moving. Formula, it's x negative something right now. So that means that we are just moving forward. We're moving forward 2 pi thirds from the origin of the function. That's pretty much it. You just grab a normal regular sine function with amplitude of 2. He's starting at 2 pi thirds.
Right.
Yeah, that's it.
I suppose you know.
So now second one is just to solve for all solutions from 0 to 2 pi, right?
I believe so. Sometimes I don't quite know what they're asking.
So for all solutions,
right, it would be 0 to 2
it would satisfy, yeah, any value that would satisfy that equation, and that will make that equation true. That's it. So which values will fit in this example that will make sine of 2x equal to sine of x?
Okay.
Because it's not, you cannot put every single value existent in that equality and say that that will always be true. So that's what we're doing. We're solving for x in this equality right there, and to find all values that can fit in there and have it still be true. For this particular case, that's what we're doing.
You know what? Let's just look at that.
Does it make sense?
Are we on now?
It does. We're still on. We haven't made it very far. And honestly,
are we on the first one?
No, we are in the second one now.
You just cut out completely.
Yeah, we are in the second one now.
Second one, okay. The sine 2x equals sine x.
Yeah.
Okay.
So this is where you would use the zero product theory.
That's when you use what?
The zero product theorem to find all the possible solutions.
Yeah, that's exactly it. You just, in this case, you're gonna use the, exactly what you're saying, the product to sum to make the 2x x, right? Then you bring the sign, and then you bring the sign to the other side being negative. So then you equal everything to 0, and then you solve it for x.
Oh, yeah. I see what you're doing. Okay. So in this case, it would be 2 cosine. It says x plus y, so it'd be 2x plus x over 2 sine 2x minus x over 2. It's just 2 cosine d3 3x2 so 2. So, William, how do you solve for all the solutions?
How do you solve for all solutions?
Yeah, how did you do that? 'Cause I'm pretty sure what I just did was wrong.
What did you get?
Well, I didn't make it any further than a phrase. I have 2 cosine times
Okay,
3x.
so you need to put everything. Like you started with sine, so you need everything to still be. You need to transform that in a way that you don't have 2 different functions, but just one. You know. So if you want to make it just all sine or whatever, but you cannot have 2 different functions.
Okay.
So in this case, I think that you can end up having. Let me just. I will grab my paper that I solved that. Let me find my paper in here.
Okay. What's wrong?
And I also got the group quiz that we're gonna be doing Wednesday.
Yeah.
I already got that done. I solved that. So
That's good. One of us is ahead of the game. Didn't you do this all last week? Must have a lot of
did I
time.
do what?
Didn't you do all of this work last week? Isn't that something you were telling us? You gonna go watch a movie?
My hat.
You don't have a hat.
For this? So what, Andrew?
Yeah. Sorry. So what formula did you plug everything in? All right. You gonna go watch? Oh, you just didn't want us to. No, I have to do homework. Oh, sorry. Too wet.
Okay, so how far did you get with that? So did you bring the sign to the left side? Is negative.
Yeah.
And then equals 0. And then for the product to sum, what did you get in that? I forgot that I did. Let me take a look.
So a product to sum. I use the or it's not product to sum, it's sum to product. Because it winds up being sine of 2x minus sine of x. So that's where I got stuck, because then I have sine x.
It's gonna be 2 sine of x cosine of x, right? Minus sine of x.
Sine of x plus y over 2, sine of x minus y over 2. You wind up with 2.
When you have actually here you have the double angle identity, right?
Do you?
So that's gonna end up being 2 sine of x cosine of x.
Oh, you're right.
So then if you factor out the sine in that case, then you end up with cosine 2 cosine.
Well, does that almost disproves this equation. Because sine of 2x doesn't equal sine of x. It equals 2 sine of x times cosine.
No, I didn't see what you said.
Well, the actual double angle identity is 2 sine times cosine.
Yeah,
and that's
2 sine
not what
times
we were.
cosine. Yeah.
Right, but we've been given sine of 2x equals sine of x.
Wait.
Now, I've got this wonderful graphing calculator. Not even using it.
Tangent over sine. That's more sine. Okay, I see what I did is this. I didn't bring the sine to the left side. I just left it in the right side. And then
Okay.
after the double angle identity, we have 2 sine of x cosine of x equals sine of x. So now if you divide both sides by cosine, then you get tangent in the right side and 2 sine in one side. So then you can now divide both sides by sine, and you're going to end up with just secant. You're going to end up with secant of x equals 2.
Okay.
Can you see it? Or?
Yeah, I can see how you got that.
Okay, so now we have secant of x equals 2. So if you do the arcsecant, then you're going to find the value for x, which is that angle that you're looking for, the first one for the solution. So each angle you have a secant of 2. You see it?
Secant of 2
Yeah, and
would either be
is 1 over
4 pi over
cosine,
3.
right?
Yeah.
So that will give us
So
pi
it either
thirds.
5 pi 3.
It's going to give us pi thirds, right? For the smallest arc, from 0 to 2 pi, that's going to be pi thirds.
Right.
Okay, so that's the first part of the solution, is pi thirds. And now, what you did to get the second part of the solution is you subtract that from 2 pi, if I'm right. Let me solve in here. So it will be pi minus pi thirds. That will give us 6 pi minus pi. That give us 5 pi thirds.
Okay.
So that's the second part of the solution. And because we just simplified as much as just having the exact value for x, then from now on we don't have to do any other thing. It's just that. So then and then in order to put in that way of all solutions that they did in the preparation kind of thing. So all you need to do is you see that from pi thirds to 5 pi thirds. So pi thirds to 5 pi thirds, you are going pretty much almost what? You're going 180 plus 60. So you're going, is that 180? Pi thirds to the, yeah, you're going 180 plus 60. So you're going 240 degrees. So then they're gonna be 2 separate things. So it's gonna be pi thirds plus k pi, k pi?
Right.
I think it's k pi.
Yeah, because it's every 180 degrees.
Is it? Let me see in here.
No, I'm wrong.
No, it's plus 2 k pi. K2 pi. I forgot how to put that.
2 pi
It's
k.
plus,
Okay.
because it's once every 2 pi that you repeat the same value of the cosecant,
Right.
of the secant. And then the separate one is gonna be the 5 pi thirds, and it's also gonna be plus 2 pi k. And that's how I remember that you do it.
All right.
Yeah, those are the two values that I would say is
I'll write that down. Okay.
yeah. Okay, that was the second question. Now, third question. So it's the same. It's the same thing. So cosine of, but in this case, we don't have a second identity. You don't have a second function. You just have cosine.
Right. But they give you what it equals.
They give you what?
They give you the
Yeah, they
equivalent.
give you what is equal, but then you need to do a r cosine, and it's gonna be different because we're gonna have an extra a step at the end, and in the value for 2x instead of x. The other side, you're gonna end up with x equals r cosine over square root of 2, which is square root of 2 over 2, right? After you do the rationalization kind of thing.
Hold on, you're getting ahead of me here.
What?
You're getting ahead of me.
Okay, so you started with cosine of 2x equals 1 over square root of 2.
Right.
That 1 over square root of 2 over 2. Because when you have a root in the denominator, rationalization, which is multiplying by the same thing, 2 by square root of 2, both in the bottom and in the numerator too.
Yeah.
So then so that 1 over square root of 2 is the same thing as square root of 2 over 2. Right?
Right.
Okay, so we are just looking for an angle that has the cosine of square root of 2 over 2, and that's pretty much pi fourths, right?
Yes.
For the smallest arc, it's gonna be pi fourths.
Yep.
So then that's our answer. So now what we do the same thing, but in this case, let me see, when does it repeat for the positive one? Oh, it's gonna be 2 pi again, and then we subtract that from we subtract that pi fourths from 2 pi again. And what we get is 4 divided by 1 is 8 pi minus pi. So we get 7 pi fourths. Right? Sign of it, of the positive one. So now we have the two of them. And so we write in that form again. So we have pi fourths minus 2 pi k. That's one thing.
Right.
And 7 pi fourths minus 2 pi k. That's the second one. But now those two, they are for 2x. We want for x just by 2. You divide the entire thing. You divide pi fourths minus 2 pi k by 2. So that's going to give you just pretty much multiply that by 1/2. Is the same thing of dividing by 2, right?
Right.
So and then in that case, what we get is that we have pi eighths, right? Pi eighths minus, and then divided by multiplying by 1/2 the 2 pi k is going to be just pi k. So you ended up with pi eighths minus pi k for the first one because you divided everything by 2. And then for the second one, you end up with 7 pi eighths minus pi k. So those are the two answers in this case. Does it make sense? Why we divided by 2?
Yeah.
Because
I'll just have
the first two angles you found, they're just for 2x, and now you need to divide it by 2 to have the right thing for x.
Right.
Yeah, that's the way I did it.
Hey, so I'm gonna have to cut this short. My wife just texted. I need to get my daughter in the bath for bedtime.
What?
It's about my daughter's bedtime, so I need to get her in the bath and get her asleep.
Do you want me
Otherwise,
to finish this with you want me to finish this with Pablo?
Pablo's gone. He said he had a fairly good grasp of it.
Okay.
So I'm not too worried about it.
So
And
do you
I'll,
think we're gonna be good?
yeah, we'll be fine. I just need to sit down and do the homework.
Okay, yeah. Because the next question, the number 4, is the same thing as the other 2 that we did previously.
Okay.
But the only difference is that now you have a tangent and a secant in the other side. But you're gonna do the same way. You're gonna just try to reduce that to just one singular function in order to solve for x at the end.
Right.
That's it. And then the 5th one is the same thing. It's the same exactly thing. So you have a sine and a cosine, and use just everything you know. I mean, trig identities and everything to reduce to one function. And then you're gonna find that you're gonna find those angles. That's the thing.
Okay.
I
Hey,
mean,
thank
no
you
big
very
deal with
much.
this one. And Wednesday when we call again, then I have the quiz that we can work on together too.
Okay. We'll make sure that Pablo
Okay.
and I send the quiz as well.
Sounds great, man. I'm sorry that was late.
No, it's all right.
Okay, I'm still using my phone.
We'll see you on Wednesday.
Okay, see you on Wednesday, man. Have a great night.